All right, today we're going to be talking just day two, some more application types of problems. First one I think is going to be really familiar from what we've kind of been doing, all right? And then number two is a little bit different, but if you get it down, then those problems are all alike, okay? So looks like example one here says Batman and Robin are lifting the bat signal light and moving it to a safe location. Batman is pushing the light with a force of 90 newtons at a 40-degree angle, while Robin is pulling the light with a force of 75 newtons at a 25-degree angle. What is the magnitude of the combined forces? Okay, so this looks like a problem where it is giving me the magnitude and the direction. And so recall, when we're trying to find the total distance of two vectors, we need to know their components, add their components together to get the resultant components, and then find the magnitude of that. So let's go ahead and do that. So it says Batman, so we're just going to go B for Batman, okay? And so the formula, remember, is the magnitude cosine times the direction, comma, the magnitude sine times the direction, right? And so it says Batman is pushing the light with a force of 90 newtons, so we're going to go 90 cosine 40 degrees, and then we're going to go 90 sine 40 degrees, okay? Let's go ahead and let's round that to the tenths. And so when we do that, we're going to get 68.9 and 57.9. So there's our component form for Batman. Let's go ahead, Robin. I know this might be a little confusing because I usually use R for resultant. Okay, but Robin is at 75 cosine 25 degrees and 75 sine 25 degrees. Okay, again, newtons are the magnitude, the angle is the direction. Okay, and so when we do that, we're going to get 68 and then 31.7. We're going to go ahead and add all those. And so we're going to get this. And I'll just use C. You can use any letter. I'll just use C for combined. Okay, and so what is that going to equal? It's going to be 136.9, comma 89.6. Okay, and there's our resultant. And so the last thing that we have to do is it just wants to know the magnitude. Okay, and so recall how you do that. You just do the square root of your resultant squared. So it's going to be 136.9 to the second power plus 89.6 to the second power. Now, I would normally be using my calculator. I already have it written down for me, the answers here, right? But you would just use your calculator there, and you would get 163.6, and let's do N for newtons. Okay? All right. Now, here's kind of the new. Okay, number two here. It says a traffic light at the Crabapple Five Corners is hanging from two wires of equal length at 15 degrees below the horizontal as shown. Okay? If the traffic light weighs 40 pounds, what is the tension? All right, so the thing that we have to understand is, okay, is that these right here, 15 degrees, 15 degrees. Can you guys see that? I hope so. Maybe I'll zoom in a little bit more here for this problem. Okay. So those are 15, 15 because that's what it told me in the problem. Okay. Now here's the thing that we have to understand, right? Before this light was put on here, our wire ran with that dotted line. Now because of equilibrium, this light just dropped a little bit, right? Just dropped a little bit, and of course that makes sense because of the weight, right? Okay. So now where the beginning of this light is here, we can draw another kind of dashed line. And so what you need to understand is because of equilibrium now, the light where it is kind of hanging now, if you were to draw a line through it, and the original line up there are parallel. Because equilibrium, because it dropped just straight down. It didn't move to the left, it didn't move to the right, it went straight down. Gravity and the force just took it straight down. Okay? So what we are trying to find is the tension. What we're trying to find is we're trying to find the tension or the weight on here. Okay? And so some other things happen to as well that now that we know that these are parallel. Okay? Well, since these two lines are parallel, okay, and because of equilibrium, the force exerted on both of these lines have to equal the same. And what do we know? What do we know about the traffic light? The traffic light weighs 40 pounds. So then the tension, okay, or the force that's being pulled down on these two wires because of equilibrium means then that each of these are exerting 20 pounds. Because what is 20 plus 20? 40 pounds. Okay? Because now we found out that these two are parallel, because of drawing this 20 pounds right here, we know that these are now both right triangles. Both right triangles because two parallels cut. Trying to think. Yeah, two parallels cut by a transversal there forms a right angle. Sorry, I don't know why brain fart there. I apologize. Okay, so we get a right triangle on both sides there, right? And now, do we have enough information then? Because we're trying to pretty much find the hypotenuse. Okay. Well, I know this is 15 degrees up here. This is also going to be 15 degrees right here, and the reason why is because two parallel lines cut by a transversal, their alternate interior angles, okay, their alternate interior angles are congruent. So now we have enough information to solve for our resultant there, or our hypotenuse, because we've got an angle and we've got a side length. We're going to have to set this up using right triangle trig, and so it's going to look like this. So what do you know from this angle here? We have opposite over hypotenuse, and so we're going to set it up like this. We're going to say sine of 15 degrees equals opposite 20 over the hypotenuse which is just S, okay, which is vector S. So now go ahead and multiply both sides. When you do that, you're now going to be left with this. You're going to be left with vector S equals 20 over sine 15 degrees. And I'm actually going to draw it because we're trying to find the magnitude, right? So not just S, we're trying to find the magnitude. So that's why I'm going to draw those absolute value signs there, right? Because we want to know how much tension is on that wire there. Okay? Well, go ahead and you're going to plug that into your calculator. 20 over sine 15 degrees, and when you do that, you're going to be left with 77.3 pounds. Okay, so when you get a problem like this, right, okay, you're going to get two right triangles here. You've got two parallel lines, okay, parallel from before the tension started and after the tension, right? Okay, because these are two parallel here, okay, and cut by a transversal, so we can form a right triangle here. Can form a right triangle, right? And so at first we didn't have enough information, but thank goodness we were given this 15 and this 15 here. So then therefore we could also make this a 15-degree angle because the transversal cut by two parallel lines. Alternate interior angles are congruent. Once you get that information, you're just going to go ahead, you're going to set up sine, because you've got opposite over hypotenuse, okay? I multiply both sides by sine, and then divided by 15, sine of 15, so you get the magnitude of S is equal to 20 over sine of 15, and there you go. 77.3 pounds, okay? We'll make sure to go over more examples of those. There is one on the homework as well. So, but that is it, guys. Okay, told you quick video today. And we'll make sure to spend a little time so that we understand it going over it in class. All right. See you guys tomorrow. Thanks. Bye.